Hey everybody, today we're talking about NVMe in the world of storage. And is it ready? Well, the answer is yes, to some degree, but it's not there yet. So be careful before you go out and say, I want to be an NVMe based storage environment and do really cool things with what I've got. The reason why I bring this up is NVMe is competent and capable. No discussion whatsoever. There's nothing wrong with NVMe. What is an issue is if NVMe is done by the PCIe bus of 3.0, which is the standard today at best. 4.0 is around the corner, but the software to use 4.0 isn't there yet. You're not going to get anything but the very basics of hardware acceleration. Unlike 3.0, which we have a lot of good development on software side, ZFS and so on, that you can actually really start taking advantage of that speed. The trick with NVMe is its bandwidth, and that's the challenge here. If you take, just like the situation happens with SSD 2.5-inch drives in a SATA controller-based model, the controller is the bottleneck. So when you have 8 or 10 or 12 SSD SATA drives in a disk array setup of some type, may it be an external one or something like that, your performance is immediately bottlenecked by the SATA interface. Now, let's say, for instance, okay, I use SAS. Well, SAS is better, but the problem with SAS is it's dual line opposed to SATA. Sorry, is serial. In other words, it writes or it reads, but SAS is write and read simultaneously. It's definitely an improvement, but it's again based on the hardware specifications. So the I/O of your SSD drives is spectacular, but the handling of the controllers is not so much. So usually what happens there is you can add multiple controllers to boost that performance up. But what about NVMe? I mean, when you got a single NVMe card like this, which has got the PCIe standard 3.0 interface down here, which is an 8X series, you realize that, okay, with this, I've saturated this port bridge through this connection. All right, so that means I've got really spectacular performance with the NVMe, which is roughly about 5 to 7%, even potentially 10% better than SSD SATA. But you know what? Can't I just put more of these guys on that same interface? Well, the answer to that question is no, you can't. Right here is an example. It looks really great. It really looks cool. There is the PCIe, and there is not the PCIe. That's a SATA bridge. And right over here, as you can see, is a SATA connector. That SATA connector is going to go to one of your SATA outputs onto the motherboard, and so you're going to have SSD performance at the SATA level, where you have NVMe performance at PCIe level. Now, this is the common problem with all of the interfaces. Why? Because the pipe to the device is just that. Now, there are a few cards out there that are just starting to come out, and they're writing software. This is what I was talking about on one of my other videos. The hardware is functional, but the software doesn't exist. Well, that's starting to improve now. There are actually RAID Claire style NVMe's that will have 2 or 4, maybe even 6 NVMe level cards which can be put on board. But here's the problem. On the side, they have a RAID controller chipset with cache, and it's RAIDing all of these on the card. For all of you old schoolers, that basically means a type of hardware RAID. So there's a BIOS on the card. You go into the card, you configure up the memory and the resources and your caching, and for all of the drives you're going to build. Let's say you're going to have a RAID 1 set of 4 NVMe cards. So your redundancy functions are there, but by the way, NVMe's do not have LEDs on them to indicate which one is what drive in case you have a failure. That's a flaw, by the way. The key thing about the NVMe interface for the controller side is that it's all localized on the card. So, what does that mean? In a nutshell, it's still one data pathway. So, you have 4 NVMe drives out there, and you build a RAID 1 controlled group, a disk group, in the controller on the card, which you had to access by the keyboard and mouse with features of your actual interface, or if it's a ZFS interface, you CLI the configuration itself. So what ends up happening there is everything is running on the card, not directly to the bus of the motherboard, as what you would do with what we call HBA mode, host bus adapter mode, where every individual single drive will come up as a single drive, and you can RAID 0 it, you can class 0 it out, or you can build into your own software or hardware configurations based on the availability and the features of your card or your local BIOS on the motherboard. In this case, when the card is involved, the card is where the BIOS is sitting, and it's going to set the RAID group up, and it becomes the bridge. So your PCIe 3.0 is here. You have a bridge interface with memory and caching, and then you have the controller chipset, which is acting as your data controller, which will write to the 4, 6, or 2 NVMe drives on this. So you're not getting NVMe performance, is what's happening. You are getting what's called a hosted performance level, driven by the PCI bus of the controller set itself. So if you were to do this, you would need several of these cards on the motherboard, and they have to run on PCIe 3 version, it recommended, because if you have anything else, it's just going to be degraded performance. And the thing is, technically speaking, let's say you can do 4 PCIe 3s cards on a motherboard. Rare, but they do exist. And you put them on, but they're shared. They're time shared. In other words, they have wait states. And that's normal with every single I/O device inside a computer. Everybody has to line up in a circle and get their card. And that's how we call it the gigahertz cycle. It runs through that cycle, every device having its rights and so on. So at that point in stage, unless you spend an inordinate amount of money on your NVMe cards, usually you'll have 1 or 2 terabyte cards in, and that will give you maybe a combination of 50 or 40 terabytes of capacity. Tops, probably more like 25 terabytes. To form that into a single group for, let's say, TrueNAS, or let's say for a local server or into Microsoft server or so on and so on, you would have to span the multiple RAID groups into what we would call a RAID 10. That's RAID 1 plus 0 configuration, where you're taking RAID 1s and you're putting them into one group. You can do the same thing with RAID 5 plus 0 or RAID 6 plus 0, but be very careful. The amount of money you've wasted is staggering. So when you try to bring all your storage together at the end of the day across, let's say, 4 PCI cards, PCIe cards, you really lost a lot of the value of NVMe in the equation, and you're performing probably slightly lower than SSD drives are in regards. So you'll perform better than a SAS drive that spins, but not like the SSDs do on their side. The only true value and benefit of this is the fact that each one of those PCIe cards have a RAID controller or they won't have an HBA controller because that won't work. They'll have just strictly a RAID controller configuration which will allow you to come into and group those devices into a common format. Now I've reached over here and I grabbed a traditional 16 PCIe Type Class 3 card. And as you can see, it's pretty large. Now this guy moves tremendous amounts of data, and today we're starting to see the software beginning to catch up to PCIe 3.0. This is not the comparable in regards to PCIe 3.8. So we got the 16 here, we have the 8 here. The factor is when a single device, as for instance you see here, a single NVMe drive here, is utilizing an 8X by itself, that's saying a lot. And that's why the RAID controllers have to do all the up-head activities that need to happen up here because it's not going to work through the bus. Now, I won't lie to you. There are definitely some industries that are out there that are starting to get around this challenge, and there's going to be PCIe 4, which will allow you to put more multiplexing effects or multipliers of cards on board, or more importantly, path more devices through a single interface. Now, still, if we have NVMe cards, multiple NVMe cards on board, those drives, those 4, 5, 6, 8, or how many cards you have on there, they have their limitation. And the fact is that limitation is the actual PCIe bus connection itself. And so that's why this is going to be a problem going down the road. Now, the last thing you're probably going to ask the question is, hey, guy, I saw this NVMe storage array, and it's out there, and it's plugging straight in. There's 24 of these guys, and they have a performance level. Well, yes, they do. But they're going through what is called a paired controller. In this regard, that controller could be InfiniBand or a variant of SAS controller interface, 12 gigabit pipes, and so on and so on. It's the controller that's dictating the performance of that type of capacity. And you'll find that a lot of times one disk array will have one or two controllers in the equation to try to get as much I/O, or what we call ops, performance per controller, because the disk array is far faster than a single controller can ever handle. And that's why in one of my previous videos I explained, hey, how can you cheat using multiple disk arrays and multiple controllers to get that performance level back up there? And I explained, well, basically the truth of the matter is that your limitation isn't the disks or the array, it's your controller, it's the bottleneck. The bottleneck battle that we fight is always there, because we make things better, better, better on the hardware side, but the software is always constantly trying to keep up with it. And it's always, unfortunately, 6 to 8 to even 10 years behind. As I explained in one of my other videos about graphics cards. You know, yeah, you go out there and buy the 4000 series card, but you're not going to get any value truly out of it and its performance matrix until the software coders really write good software to take advantage of that. And it's the same case with other platforms. The reason why NVMe disk arrays exist is for two key reasons. One, the controllers dictate the enterprise requirements that the arrays will provide. Will they improve down the road? Absolutely. But the controller is also the bottleneck. And two, money. Yeah. Hey, I can sell you this NVMe guy for $50,000 opposed to a SAS spinning disk array for $10,000. And I can give you X, Y, and Z level of NVMe-like performance. Well, the truth is, not really. Yeah, you're going to get NVMe functionality. But when it comes back to that controller, unless you really try to span those controller interfaces out, that's the challenge. But it's still enterprise equivalency. So yeah, it will work in a enterprise data center environment, or into a distribution center, or into a cloud environment. It will perform pretty nicely. It's just not what you would expect when you add up all the I/O that is available in your NVMe cards, over 1 million I/O. But you're seeing 450,000 or something like that. So anyways, this is Brad Dyke. I'm signing off. I hope you enjoyed the video. If you like it, please like, and God bless, and have a great weekend.